Hey guys, Mr. Backberg here. In this video, we're going to look at triangle area and Heron's formula. Now, we should already know that one way to find the area of a triangle is by taking 1/2 times the length of the base times the height of the triangle. But we don't always know the exact height of our triangle, so that can be a little tricky sometimes. But there are going to be a couple of other ways that we can find the area of a triangle depending on the information that we've got. So here we're going to look at finding the area of a triangle given two sides and the included angle. So we've got this triangle to take a look at on the right-hand side where we've got angles A, B, and C, and we've got sides little a, little b, and little c. Now there's actually three different forms to this area formula just based on the information that we've got, but in each case we should recognize that it's two sides and the angle between them. So like as we look at this first one where it's 1/2 times A times B times the sine of angle C, side A is right here, side B is right here, and then angle C is between those. So it's two sides and the included angle. Same thing over here if we look at this one where it's 1/2 AC times the sine of B. Here's little a, here's little c, angle B is between them. And then as we look at this one, 1/2 BC times the sine of A. There's B, there's C, and angle A is between them. So as we're taking a look at this first example, we're going to find the area of a regular polygon. And what we're going to look at is a regular octagon that's inscribed in a circle that has a radius of 9 inches. So as we're taking a look at this picture, being inscribed inside of a circle means that our shape is inside the circle with our vertices, our corners of our shape, intersecting the edge of the circle. So what we can actually do in here is I'm going to draw in a couple of radii on my circle. So going from the center out to the edge, but I'm going to do so where one of those vertices of our octagon intersects our circle. And I'm going to draw another one over here to form that triangle. Now we know that our radius is 9 inches, so this length is 9 and this length is 9. Based on what we were just talking about with those area formulas, we need two sides and the included angle. So it would be really helpful if we knew how big this angle theta was in here. But here's what we can actually do. Because we're dealing with a regular octagon, we're actually going to be able to split this into 8 different congruent triangles, all of them being exactly the same size. Now we know if we make one full circle all the way around in terms of degrees, that's 360. But if we split that up equally amongst these 8 different triangles that we're creating in here, then each one of those central angles, each one of those theta angles, ends up being a 45-degree angle. So I can use that to help me find the area. So what I would do is the area is equal to 1/2 times one of the sides times the other side times the sine of the angle included between those sides. And we just said that was a 45-degree angle. Now before we type this into our calculator, we are going to have to make sure that we switch over into degree mode. So if I type this into my calculator, I get about 28.64. But that's just for one of these triangles, and I want to find the area for the entire octagon. So I have to remember that there are 8 congruent triangles in here. So I have to take this value that we just got, and I need to multiply that by 8. So when we do that, our final answer that we get should be about 229.10 square inches as the area of that regular octagon. Now there is also a way that we can find a triangle's area even if all we know is the length of its sides. And we're going to use something called Heron's formula. So as we're taking a look at this triangle with angles A, B, C and sides little a, little b, and little c, the first thing we actually need to calculate in here is this S value. And S is called the semi-perimeter. So we add up the sides, but then we divide it by 2. Then in order to find the area, what we do is the square root of S times S minus A times S minus B times S minus C. So as we take a look at this example, we're going to use Heron's formula to find the area of a triangle with side lengths of 13, 15, and 18. So the first thing we want to calculate is the semi-perimeter. So we're going to take the 3 lengths that we were given for our triangle, add them together, but then divide by 2. Now when we do that, we should get 23 as our semi-perimeter. So then in order to find the area, we're supposed to do the square root of that S value of 23 times S minus A, which we'll say is 13, times S minus B, which we'll say is the 15, times S minus C, which we'll say is the 18. Now when we do this subtraction inside here, this first set of parentheses is going to be 10, this second set is going to be 8, and this last set is going to be 5. So underneath our radical, I'm going to take 23 times 10 times 8 times 5. So we should get the square root of 9,200. So if we type that into our calculator, we get about 95.92 as the area of our triangle. That's going to be it for this video. Thanks for watching.